Good morning, everyone. Welcome to this AECB webinar, which is an introduction to the AECB's building standard with Mark Siddall. Mark is the owner of the lovingly engineered architectural practice LEAP. Mark is also an AECB group leader for the North. Mark is also an AECB trustee and also sits on the AECB technical panel for the building standards and everything else. So without further ado, I'll hand you over to Mark, who'll do a presentation. We hope to get done within the hour, and there'll be time at the end for some Q&A. I'll also put in the chat box shortly some links to the building standard page, etc. for you all. Over to you, Mark.
Thank you very much, James. Thank you. Okay, so yes, welcome to the introduction to the AECB Building Standards, plural really. Without any more hanging around, let's get on with it. So, a quick bit of context. If you don't know me already, then as you just heard, I'm an architect and trustee of the AECB. In terms of things that kind of help draw this together, is the recognition of the IPCC's report on climate change, the recognition that biodiversity is also threatened, and also how buildings play a part in this, not only through their contribution to carbon emissions as an existing building, but also because of performance gaps. And that's the thing that sort of kind of focused my mind professionally. And then basically thinking about the future generations here. There's been my daughter here. And also then thinking about Greta and her thoughts and contributions really. For the next generation. So basically my theory here is the one was, if you're aware of a problem, then it's your responsibility to act and address those issues. Or in the words of Greta, I want you to act as if the house is on fire, because it is. So the building standard, the AECB building standard. Now, this first part of the presentation is really going to focus on the new build side of things, and I'll touch very lightly later on retrofit. But there is a more in-depth presentation that's going to be made by Sarah Price on the retrofit standard as a standalone presentation. So you'll be able to really ask more detailed questions about retrofit on that webinar. Okay, so the building standard itself is an overarching umbrella, should we say. There's a core part which is compulsory, and that relates to energy. And then there are complementary and voluntary sections that deal with water, lifetime carbon, and daylighting. In terms of the AECB building standards history, then basically we can go back to as far as 2005, when the energy standards were first published under the auspices of gold and silver standard. And in 2007, the AECB then ushered in Passivhaus to the UK and updated the standards accordingly, introduced the water standards in 2008, and then has gone through a few tweaks and changes. And then in 2020, we've drawn together a number of different things that were kind of in the background and had been underway, which brought the water standard to kind of a clearer prominence as part of the AECB building standard itself, along with daylight and life cycle carbon. So the question here would be, which of these buildings, are AECB building standard or Passivhaus, or anything that you might care to respect? There's new build, there's existing retrofits. All these kind of buildings have been realised to the AECB building standard. The energy standard itself, well, basically it breaks down in some fairly straightforward and simple metrics, and underpinned by all of this is actually intention to and consideration for health and well-being, air quality, comfort, and the likes. But it can be distilled into these kind of key headings here. In terms of delivered heat or cooling, then in terms of following the Passivhaus methodology here, then we're basically relating the specific heat demand or cooling demand to less than 40 kilowatt hours per metre square per annum. Now, in the UK climate, I hasten to add, we don't really consider that cooling should be a necessity, though in certain building typologies it may be, and therefore we're keeping that window open. But the majority of the time, cooling shouldn't really be something that's, mechanical cooling at least, it shouldn't be something that we're concerned about. Primary energy demand, well, I'll touch a bit more on that later. There's primary energy demand or primary energy renewable, and this varies. related to the building standard itself, and over time, because different locations, different countries have got different targets, so that all tie in with the use of PHPP, the Passivhaus planning package. And I'll touch on a bit more on that a little bit later. In terms of new build, we're talking about an air tightness target of 1.5 air changes per hour at 50 pascals when we're using MVHR. And well, currently there's still some tolerance here for the use of MEV with a slightly higher leakage of 3 air changes per hour, though we'd argue that really these days AECB members should be trying to target the 1.5 on all projects. In terms of thermal bridging, then again, following the Passivhaus methodology, we're using external dimensions. Certified Passivhaus designers will know what I mean by that. And therefore, we're looking for an external psi value of less than 0.01 watts per meter Kelvin. So in all conditions, the design should be considered thermal bridge free, or alternatively, you're calculating thermal bridges. In terms of dealing with summer comfort and addressing overheating risks, then what we're, again, in alignment with Passivhaus approaches, we're limiting the exceedance of 25 degrees Celsius to less than 10% of the year, though less than 5% is certainly recommended. And good practice, best practice would be targeting less than 2%. Okay, so you might be wondering, what does this look like? How do we deliver an AECB building standard building? What kind of specifications might we be focusing on here? So this table sets this out. What we have is we've got an MEV strategy looking at the columns. I'll just use my cursor here. So we're looking at the columns here. We've got an MEV based strategy for a semi-detached property, an MVHR, two MVHR strategies with an air tightness of 1.5, and then we've got some terraces here as well. So I thought these would be useful and give you some strategic insight in terms of the kinds of specifications that you might end up with. But of course, this is sensitive to your particular design, depending on how your form factor, the surface area to floor area ratio, that is, and also the amount of glazing that you might be including, etc. So right, to focus on the MEV based strategy here, what we've done is we can see that we've got U values in the order of 0.1 for the roof, 0.08 for the walls and floors, 0.85 for doors and windows, with our psi values, thermal bridging coefficients, all being satisfactory. The specific fan power of the MVHR system is less than 0.35 watt-hours per meter cubed. Again, tying in with Passivhaus kind of approaches here. And the space heating demand target, in this case, well, we're failing. We're ending up with less than 50 kilowatt-hours per meter square per annum. So we know that we need to do something different in this particular scenario. So, and this is where we're using a northwest or northeast based climate zone as an example. But we're in the right sort of territory for renewables and the likes. Now, in failing the space heating demand target, we also have we've got to be mindful that we've also got our primary energy or PER targets that we can that we're working with as well. With the semi-detached example here in the middle, then what we're now doing is we've now included MVHR rather than MEV, and therefore that has quite an impact upon the specifications. The fabric standards requirements become a lot less onerous by including the MVHR, and that also means that we eliminate some of the drafts and discomfort that could potentially occur with a poorly designed MEV system. But again, yeah, it becomes somewhat more affordable to do under this scenario here. And then we're now into a territory whereby we're satisfying the 40 kilowatt-hours per meter square per annum for the space heating demand target. But that also then means that when we're dealing with the primary energy or primary energy renewable side of things, we've got a lot less tolerance left in that section of the specification. So what we could then start to do is think about the next column, whereby we actually start to improve our space heating demand target. We get down to 20 kilowatt hours per meter square, and in doing so, that frees up a little bit more on the primary energy side for us to get into kind of suitable certifiable territories there. Of course, the next step would be to think, well, how about not doing semi-detached if we did a terrace instead? So these two terraces of 5 and 8 dwellings show again how by bundling the houses together into a terrace, we improve the form factor, and therefore we can get more relaxed U values, whilst also satisfying the space heating demand targets. Now, of course, you can improve those fabric standards that bit to create the right kinds of tolerance there to get out of the need for having to specify renewables in order to achieve the primary energy demand targets. If you've got any questions about that, I'll answer these at the end. Okay, so in terms of thinking about the PER strategy, obviously we can introduce the water standards, because the water standards are focused upon domestic hot water use, and therefore we end up with less energy being used from that. We can also include drain water heat recovery, again, quite a neat, tidy, passive approach. And then we're starting to think of best-in-class appliances rather than thinking about renewables up front. And yeah, this is a more sensible approach, though it's obviously, because it's a lot more cost effective to introduce energy efficient appliances than it is to install renewables. Now, this obviously gets into some certain situations or conversations that you might have if you're you're providing social housing and things, but in terms of best practice, this is kind of a bit of a hierarchy that we tend to think about. Okay, so why would you want to build to the AECB Building Standard? Well, quite frankly, not everybody is brave enough to start off with a passive house straight away. Designed plenty myself, but working with clients that have worked on AECB Building Standard projects, then yeah, there's certainly that hesitation that can arise for a range of different reasons. And this can relate to real or otherwise concerns about build cost. We know that passive house buildings don't necessarily have to cost a great deal more if we're talking about residential, and there's some great information from the Passive House Trust on that. But the AECB Building Standard offers a kind of that backstop, which can be a bit more reassuring to those that are concerned about costs in those ways. And then also there's a lower cost of certification when the architect, designer or engineer that's undertaking that certification work is part of the design team. If you introduce an external certifier, then there are going to be similar additional costs to that of certifying passive house building. And then also the AECB Building Standard works as a very good near miss. If for some reason you haven't hit the air tightness targets that you were aiming to achieve, or there's thermal bridging or specification changes that might have happened, then perhaps the AECB Building Standard becomes a fallback position that could be adopted. Also, you have the scenario whereby you've got a bit more flexibility in terms of design. The space heating demand is less target. It's somewhere in the range of typically between 16 and 40 kilowatt hours. Though we could argue that because it's less than 40, technically passive house falls within this kind of remit here. So therefore, you end up with certain kinds of flexibility that might not otherwise be the case, and that might be beneficial when you're dealing with certain cost concerns or particular contractors, perhaps. The relaxed space heating demand target places greater emphasis upon designing the PER or primary energy renewables in an appropriate way, and allows more focus to be placed upon efficient appliances and renewables in that regard. I'd argue that we want to be keeping the space heating demand down as low as possible, nonetheless. And in terms of air tightness, one of the concerns that often gets flagged up by contractors that are not familiar with design, with building very airtight buildings is, how airtight should we be building, and how can we do it, and will we achieve it? And they're concerned about liabilities that could arise from that. So the more relaxed air tightness targets can be somewhat reassuring to contractors. That said, there are plenty of new build projects, self-build projects that are achieving some very high standards. So house builders that have not built passive houses before are achieving an air tightness of 0.1, for instance. So there's no reason why an AECB building standard project couldn't do something similar. And then, of course, from the specification point of view, there is that flexibility to have in terms of thinking about ventilation strategies, whether you're using mechanical extract ventilation or mechanical ventilation with heat recovery. And finally, when we compare a lot of UK development, UK homes to houses elsewhere in the world, then UK houses are smaller, and therefore there's a more challenging form factor. And that, for what that means, is that we can end up with needing to put more insulation onto the building than may otherwise be the case elsewhere in the world, where the houses are that much larger. And this again goes back to achieving the space heating demand target. Okay, so some critical questions and things that crop up from time to time when we're answering technical queries is, what are the boundary conditions? How do we set up PHPP, the Passive House Planning Package, in the right way? Just as a bit of a background, if you're not familiar with PHPP, then this is the design tool that's used when we're designing an AECB Building Standard project or building. And it's also used in PHPP, Passive House design as well. And this sets all of the context, all of the thinking, all of the boundary conditions, so that we can make sure that we're closing performance gaps and we're delivering buildings that design as we would expect. Now, there are a couple of different toggles in the on the verification worksheet, sorry. And what we'd do for an AECB Building Standard project is we set it so that the PHPP is looking at the project as a PHI low energy building. And this is important because it has an impact upon the primary energy renewable kind of options, should we say, selection that crops up a little bit further on down here. We have it as in a classic class, should we say. We're not looking at premium, kind of passive house premium as an example. We're just leaving it classic for now. Verification of primary energy. Well, you can go under an either-or approach. Primary energy non-renewable or PER, primary energy renewable. And then if it's new build or retrofit, then you make the appropriate selection in that regard as well. Now, one thing to highlight here is that with Passive House Classic, then we're talking about a primary energy target of about 135 or less than 135 kilowatt hours per meter square per annum. Or if you didn't kind of select the classic approach, then the PER would be 60 kilowatt hours per meter square per annum. With a PHI low energy building specification, then you get a slightly more relaxed performance target here. So what we're saying is that we recognize that the fabric, we're relaxing the primary energy renewables target so that we're not forcing projects to have renewables necessarily, depending upon whatever specification that you've got. And here it's also worth recognizing that MVHR units that are not Passive House certified have also got to be considered in an appropriate way. What this means is that as per the Passive House standard, and as all Passive House designers will recognize, if it's not a Passive House certified MVHR unit, then you would suffer a 12% point performance penalty. And what this means is that if you've got a 90% efficient MVHR system, you deduct 12 percentage points. So therefore, the effective efficiency would be 78%. Okay. Now, there's some great information on the Passive House Passipedia website here. So I'm not going to go into too much detail, but basically PER, the primary energy renewable, considers, should we say, a future state of the grid, whereby we're using a lot of, where we're using primary energy, and we are sorry, I've lost my train of thought. So we've got the primary energy, and it's not to say that that is entirely carbon neutral. There are costs to this, inefficiencies in the system, and primary energy renewable takes this into account. Within the AECB Building Standard, just like Passivhaus, we're designed to recognise comfort. So ISO 7730, we're considering radiant comfort, risks of downdrafts from windows, from radiators, etc. And also stratified air temperatures are also another consideration. So that's another reason why we want to make sure that we get the window specifications right and the heating strategies correct as well. So kind of, we get the next kind of question ends up being, well, what U value should we be targeting? Do we need to put radiators underneath the windows? And what about curtains and shutters? On the next graph or so, I'll show you how we can think about U values that tie in with comfort. In terms of radiators, well, you can put the radiators below a window, but we don't need to. If we've designed good adequate windows in the first place, then we can put them elsewhere in a dwelling. And curtains and shutters themselves, well, they're transient in use. We don't always know that they're always being used, so we don't kind of consider those as having an impact upon thermal performance from a space heating demand perspective. Here we are. So yes, when we're thinking about a window U value here, then you could use this graph. This is something that I actually worked out a number of years ago, based upon the paper that's written down below. And what we can do is, looking along the horizontal axes, you can look at the height of the window, and on the vertical axes we've got a range of indicative U values. The orange, blue and magenta lines indicate external design temperatures that you might be considering. So we've got something going here from minus 10, minus 5 and minus 15. What we're saying here is that for the magenta line, that is a minus 5, so that's reasonably kind of respective of the UK scenario here. And then we've eliminated, if you use this information, you've, broadly speaking, eliminated the risk of downdrafts. Always checking this out for yourself, make sure I haven't made any mistakes, but hopefully this is a good indicator for you. So you'll be able to just use this as a bit of a lookup. Now, what we don't want to have is too relaxed a U value, because that would result in condensation risk. So there is a cap to how high the U values would be, and that's about 1.4. But anything less than that generally starts to work itself into the right sort of position there. Okay, when you're making a submission for the AECB Building Standard, then there is supporting evidence that's required, and that's all down on the website, as you'll be able to see. If you follow this, type this link in, or if you follow one of the links that I think James will have put into the chat, you'll be able to find the guidance notes telling you what information should be submitted as part of your AECB Building Standard submission. Who can certify your project? Well, basically, so that we know that people have got the right kind of knowledge and understanding here, then we're talking about certified Passivhaus designers. Which so you might go to Passivhaus training, for instance, and train up to become a certified Passivhaus designer. If you are if you're an experienced certified Passivhaus designer, you may be on the Passivhaus Institute's register, but you may also have experience and not be registered, and that's okay as well. You don't, we're not necessarily kind of looking for that at the moment. Many of the people that are able to certify a project are members of the AECB. So if you're looking to find a certifier, then I'd strongly suggest that you go and have a look at the members directory and look for somebody in your region. Who can design your project? Much in the same way, ideally people that can demonstrate experience with working on AECB Building Standard projects. Again, certified Passivhaus designers are kind of are a good fit here, but they don't need to be certified Passivhaus designers necessarily. The key thing would be making sure that they've worked on certified projects, or that they've got some good air tightness results before, and that they know what they're doing. And you can make different inquiries to help support that. Who can build your project? Again, certified Passivhaus tradespeople are very much in tune with what we're talking about here. They understand the quality of construction that's required. Alternatively, experienced contractors that have already worked on certified AECB building projects and delivered high standards of airtightness on previous projects as well. Experienced certifiers can offer trades training to help support the contractors while they're working on site, and an experienced AECB certifier can also support architects, engineers, and the likes as they're working on projects as well. When we're talking about applying the AECB building standard to retrofit, well, to tell you the truth, there is the retrofit standard, which I'll be talking about a little bit later. You could use the AECB building standard as a backstop in terms of the 40 kilowatt hours per meter square space heat demand target. But though there are relaxations if you go through the orthodoxy, shall we say, of the retrofit standard, and as I say, I'll be talking about that. And there are some key differences between the AECB building standard and the retrofit standard when it comes to dealing with moisture, and that's a really critical concern. So keep in tune if you're keep an eye on this if you for later on. And if you want to become a suitable retrofit consultant, then you might consider going on the Carbon Light retrofit course, CLR retrofit course, and this also counts as 35 CPD, continuing professional development points towards your your Passivhaus certification as a certified designer. Extensions and additions. Basically, these shouldn't be considered in isolation. We should be thinking about a whole building retrofit plan, and where appropriate, this is kind of a more considered and responsible approach. Every project should be considering a retrofit strategy if you're extending a building. Also, it's more cost effective as an approach. Certification costs and modeling. Well, basically, there are different strategies that you could adopt, or your certifier could adopt. One approach is the dwelling by dwelling approach, and this tends to work out somewhat more expensive because you're having to certify each individual property. And you need to take those dwellings and you need to break them down into an energy subtype, because we might have end terrace units, mid terrace units, and technically we might think of them as the same house type in terms of floor plan, but they've got different characteristics in terms of energy use. So therefore, that's why it can add some additional costs. Building by building, if we actually kind of create a strategy whereby we're looking at the whole building, so this could be flats, for instance, then we would take the whole building, we'd be certifying that rather than each individual flat, or we could be certifying an entire terrace as a building rather than individual dwellings in that terrace. Then this is a lot more cost effective, and this is a strategy that's normally endorsed and supported by Passivhaus certifiers, for example. So we know that and given that we're working in keeping with that methodology, this is a sound approach, and it's what we would advise. But we also know that some people like to certify on a kind of dwelling by dwelling building type approach, simply because they can then might have commercial value in terms of selling each individual plot with its own certification, for instance. Certification costs for clients. Well, basically the AECB certification fee is not a total fee. So if you go on the website, you'll see that that's not the total fee. That is basically the fee for getting the certification registration process completed. There are additional costs that a client might face because there's obviously time that goes into building a PHPP model, informing the design development process, supporting the trades on site, site inspections, etc. Which is why we strongly suggest that you would use a member of your design team as your certifier, because they will be, they'll be doing a lot of these things as part of their natural process, shall we say, as your architect, as an engineer, and undertaking site inspections and things. To split it out and have an additional party involved does add more cost than you might necessarily have been thinking about. The AECB Building Standard, Daylight Standard, sorry, integrates fully with the AECB Building Standard because it's basically, basically what we're doing here is we're helping to focus on the winter well-being, reducing seasonal affective disorder. We're thinking about by getting good standards of daylight, we're not overglazing a window, overglazing a building, and which can result in overheating risks. And we're also avoiding glare and gloom and discomfort from that, whilst controlling and limiting the amount of artificial daylight that would be used throughout the course of a year. So, and also another key thing is to recognise that windows are often more expensive than wall. So right sizing of your windows works well for budgets. So if you've got a strict budget, the daylight standard works well in that respect. You know that you're not going to be providing too little daylight. And also, whilst you'll also be managing some of these other issues as well. Now, daylight factors themselves are relatively quick and simple to calculate. Daylight factors were first developed in the UK in the 20th century, and it's basically a ratio between the amount of illumination outside and the amount of illumination that gets inside. And they're quite straightforward. A range of different tools available that can calculate daylight factors, some of which are listed here. Dilux is one example. And it's a static measure. It doesn't take account of orientation, time of the year necessarily. It's basically working on a standard overcast sky out there, and then working things out on the basis and relative to that. There are several ways to calculate daylight. There are those advocates, and many that can say that daylight factors have limitations, and they do. But for domestic purposes and for the speed of iteration, it's generally found that they're quite useful. When designing with daylight, we can consider direct daylight, but direct daylight can be annoying in some circumstances when we're trying to work, but it can also be quite pleasant when relaxing. So we've got to think about the kind of lighting that we're going to be creating in a particular property at a particular point in time. In terms of daylight modeling, you're only as good as your inputs, so making sure that you consider things like external objects, the true size of glazing, not just about structural openings. So your glass area, the solar transmittance of the glass, and the reflectance internally are also all kind of key characteristics that we need to consider when we're developing a good design. And that's where the AECB daylight standard kicks in as a steady state model, a simple spreadsheet in effect. It's based upon BS 8206 Part 2 and informed by various other bits of guidance from the BRE. And what we're looking to achieve is adequate daylight for around about 70% of the year, and acceptable daylight for 80% of the year, roughly between the hours of 10 AM and 2 PM. So that's at the end of the year. Daylight uniformity is something else that's considered, so we don't get kind of gloomy areas at the back of a room, for instance. We're looking to achieve a daylight uniformity of around about 80% here. The calculation method that we're using can also integrate very well with BREEAM projects and HQM House and Quality Mark projects as well, because we're all founded on the same kind of British standard here. What we're talking about is basically we've got different kinds of room type here, and on the right hand side we've got some daylight factors. These are all kind of kept with tables in the guidance note, which you'll find at aecb.net. Following that hyperlink down below. The output from the daylight tool when we're making a submission is possible through pH ribbon, which I'll be talking about in a little bit more detail later. But basically, you've got you're pulling together the building, the client, the consultant that's undertaking the work, and whether the whether the design is achieving everything that is intended here. And there are circumstances whereby this is more of a guidance. The most important thing is that you've actually undertaken the calculations and you have a good understanding of what the impacts are. There are borderline conditions that can arise, and these are something that should be discussed with the client, but it's at the certifier's discretion whether that should be considered appropriate. So there's a quick start guide approach, so creating prototype rooms that are available through the daylight spreadsheet. And then you can refine and update the model using your PHPP as part of your normal workflow. And then one of the key things that we recommend is that you kind of calibrate your experience with working with the tool. So go down to site, measure the daylight factors in practice, and start to kind of get your own intuitive understanding about performance here, and also do some long-term data monitoring as well to assess overheating risks, and look for those correlations where you can build your confidence in the approach. But it's the feedback loop which is very important here. In terms of dealing with the AECB water standard, there are 2 volumes of guidance on the AECB website, and you can go through those in your own time. Key things to recognize here is that basically hot water is the major concern that we should have from an environmental perspective in terms of its carbon emissions. Basically the majority of the carbon emissions are made in the home from our domestic hot water, not through the treatment process associated with the water coming to our houses. Now, we also obviously need to think about the volume, the quantity of water that we're using, but as designers, we've got, and specifiers, we've only got a limited amount of scope to control that. Obviously, the key thing is people are going to use as much water as they feel they need or feel is appropriate. So what we'd be saying here, this is where it gets back down to thinking about the kinds of fittings that are used, and thinking about dead legs and the likes. So what we can see here is we've got the standard household domestic hot water carbon emissions, and the key thing to recognize here is that we've got water use that happens, and this is, as I say, designers don't have too much control over that specifically. But what we do have a greater influence over is cylinder losses and dead legs and secondary circulation loops and the likes. We can also, of course, be helping to reduce the overall quantity of water that is being used by specifying low flow taps and appliances. But we've got to do this in a thoughtful and appropriate way, so that we're making sure that there's appropriate comfort being considered along that in that process. So some work that was done by Nick Grant and Alan Clark a number of years ago, along with Dr. Judith Thornton, looked at the amount of energy that was being used and in dwellings. And what we can see is that there can be some quite considerable. We've got the amount of delivered water along this bottom line here, and we've got the useful internal gains that can arise here. We've also got the hot water system losses, which is the key thing that we're focusing on here, is the green. And then so there's a lot that can be done in terms of tidying up the amount of water, amount of energy that's been used by designing and specifying the pipes, and as well as the insulation and the appliances, the taps that are being used in the property. The water standards themselves set performance values for individual devices, and it results in a cost-effective design which is user-focused and has a cautious approach towards innovative technologies. So we're not encouraging people to undersize baths, and also we're thinking about the runoff time from a hot water system, storage cylinder, for instance, to the tap. We're not waiting for hot water to arrive for a long time. It should arrive in quite a short period of time. So one project I worked on, Siddall Farm, we did use the AECB water standards, and hot water gets from the cylinder to your hands in less than 10 seconds. So therefore, and that's at the furthest point from the cylinder. So we know that we've got good hot water arriving quickly, and that's a good positive experience. And doesn't encourage so therefore you're not encouraged, should we say, to rip out a tap because you're having to wait for far too long for the water to arrive. Another key thing is controlling the volume of water within a dead leg. So therefore, because all of that heating up that pipe and all the water sitting in that pipe over a period of time is also a heat loss, and that's not a beneficial thing to have. So we need to pay attention to that, and that's another factor that's considered. And then this is courtesy of I think Harry Pathicus highlighted this in the presentation he did. But yeah, basically using flow cups to measure weir gauges to measure the amount of flow off a tap, and commission the building appropriately. So it's a quick start guide for the water standards, and thanks to Harry Paticus for this. So basically, carry out the research early, test the water pressure at an early stage, because we want to make sure, because there are pressure losses with micro bore plumbing. Most of the time it's okay. I'm not experienced any problems over the last 15 years or so of using this, but nonetheless, it's something that we need to always be wary of, or be cautious. Go and check first. You want to work with a good service engineer or passive house designer that's worked with the AECB water standards before. Consider the shortest pipe work runs. So thinking about your services layouts. Architects amongst you, if I said design with kind of a shell and core frame of mind, you might get what I mean there. Making sure that basically all the services are clustered together and all lined through neatly. Think about landscaping proposals, and water butts and the likes, checking best practice to make sure you're on target. So you're reviewing specifications and calculations. In terms of dealing with the lifetime carbon standard, again, this sits under the AECB Building Standard, but can also be you can also integrate it with the retrofit standard as well. So basically, there are the key thing here is making sure that you undertake two sets of life cycle analysis, looking at the embodied energy and the energy in use, and you're basically comparing these two buildings, these two designs with one another, and you're selecting the best practice option. We're not setting specific numerical targets at this particular juncture. It's the methodology that we're trying to get embedded. We know that AECB members are obviously very much more conscious of emissions that arise through life cycle energy use, and therefore we're currently gathering the data to then set appropriate standards in the future by basically by drawing from that best practice data set. pH ribbon is the tool that's used to calculate the embodied carbon. Again, this uses, because it integrates very neatly with PHPP, a lot of the geometric information that has been entered into PHPP is then ripped through and pulled into pH ribbon. So it streamlines the whole workflow and makes the cost of calculating embodied carbon that much less, and simplifies the process at the same time, whilst also helping us as the AECB ensure that the quality is being maintained in that same process. If you want to know more about this, then AECB members obviously have access to a lot of Tim's webinars talking about pH ribbon, and he's got some real life examples and talks about materials and embodied carbon in the AECB webinar program, which you, as a member, you have automatic access to. In terms of the retrofit standard, which is the new kid on the block, as it were, and as I say, Sarah Price has got an upcoming webinar on this, so keep your eye out for that. But if you are working on retrofit, then here's a quick overview. Basically, the retrofit standard, we have two components, which are basically core and compulsory. This is energy and moisture. Now, this is because when we're dealing with an existing building, there can be a lot of existing moisture issues that need to be addressed, and you don't want to do things in the wrong order. So this is where really making sure that your architect, your designer, or whoever, you've got the right consultants on board to help supervise and advise the design process when you're undertaking a retrofit. Now, sometimes we find that you might also, when you're retrofitting an extension or an addition or a conversion, a loft conversion, for instance, might be part of the retrofit process. And therefore, we're talking about, you can also integrate the water standard, lifetime carbon standard, and daylighting standards into an AECB retrofit process as well. In terms of the overall performance targets for your retrofit, then we're talking about, normally we're talking about a target of 50 kilowatt hours per meter square per annum, though this, with some exemptions, as you'll hear about in Sarah's presentation, that can increase to something near 100 kilowatt hours per meter square per annum. Primary energy targets, well, basically must be filled in the manner that we've talked about earlier on, but there's no specific certification target number that we're talking about at this particular point. The air tightness target, we're now saying for existing homes in the UK, and then an air tightness target of 2 air changes per hour at 50 pascals, whether it's MEV or MVHR. That applies in both cases. Same kind of performance requirements for thermal bridging. Whenever there's a thermal bridge that has a thermal bridging coefficient of greater than 0.01 watts per meter Kelvin, then those calculations would be required. And again, certified passive house designers know how to can make that kind of assessment. Overheating risks, again, what we'd say is you want to be definitely less than 10% with no opening windows, and less than 2% with an opening window. And following good practice approaches there. And also, finally, and this gets back to the moisture-related considerations here, making sure that the surface condensation risk, the FRSI as it's known, is greater than 0.75. We have a series of exemptions that do apply, which is why you might we get the relaxation from 50 to 100, and that can be where you've got buildings of specific historic value, or there could be some certain legal requirements. There could be limitations in terms of what you can do practically in terms of thickness of insulation, or there could be fire property, certain properties that need to be considered in a particular way. Or when you're considering internal insulation systems, moisture robust construction can be important, or is important, and therefore we need to make sure that we don't over specify the thermal performance of a particular building. And there may be other compelling reasons relating to construction that could also be worth consideration there. So your certifier, your AECB certifier, would be able to kind of make that review and determine what is they consider appropriate. And they can always refer back to the technical support at the AECB if they've got particular queries. One thing to highlight is that a full conditions survey and retrofit risk report should be compiled, and this would so basically there's 2 key sections to this: information from a pre-retrofit condition survey, and then also a description of the pre and post retrofit risks. So if you commission an RICS level 4 survey, for instance, that would be a building survey, and that would get you your pre-retrofit condition, but the surveyor may not be equipped, unless they're a certified passive house designer or a retrofit coordinator or somebody that's worked on AECB retrofits before. They might not be equipped with the right level of knowledge and understanding to actually anticipate the impact of a retrofit upon the project. So you've got to have these 2 elements brought to bear on any given project. And when we talk about new additions in a retrofit scenario, again, it's difficult to gauge when you're doing your PHPP what the U value should be for the new addition. So basically, what we're saying is that there's an indicator here. We'd expect that backstop would be 0.25 watts per meter square Kelvin, but space permitting, then obviously moving to a U value of less than 0.15 would be well worthwhile. And from a design approach, it's we can't actually measure it, but we'd certainly be sort of supporting the approach whereby the extension should achieve an air tightness of less than 1 air change per hour at 50 pascals. There's no reason why a new build couldn't. But as I say, developing a test, we were not expecting you to develop a test regime for that. It's more one of how you approach it as a certified passive house designer, as a certifier, to ensure that the quality of the design is in place. You get paying appropriate attention to thermal bridging, similarly with window design and ventilation, as per the retrofit standard. How is a project certified? As we move towards the end of the presentation now, so basically there are different phases to this process. First of all, we're basically developing some prototype analysis for new build or for retrofits, and optimizing a design, all prior to undertaking a planning application. So we've got so there's a bit of iteration that's going on. We're doing some initial checks, determining whether we're satisfying the performance criteria, and if we're not, updating the design accordingly before we make a planning application. Next, we move towards making a kind of a more detailed PHPP analysis that takes on board the more detailed kind of specifications, and that would be developed as prior to a building regulations application, for instance. And again, we go through iterative processes here to make sure that the design is on target. Then at that building regulations stage, then we could go forwards. You can develop documentation as necessary to get to the point of going out to tender and building the project. Again, with iterative processes, any changes that are made or proposed should be checked and verified in that process prior to completion, so that way you can make sure that you're on track. But assuming that all things are present correct by the end of that process, you can then certify your project. Your certifier will then make a submission to the AECB and register the project in the appropriate way. In terms of declarations and submissions, complementary AECB standards that are adopted must be submitted as part of your building standards submission. So the verification sheets for each standard must be combined into a single PDF and uploaded as the PHPP verification sheet on the Low Energy Buildings database. If you go to the Low Energy Buildings database, lowenergybuildings.org.uk, that's where we register AECB building projects, whether it's retrofits or new build. Basically, your certifier will have a login and they can register, log in, go into their account and introduce the new project to the database. At the end of which, once it's been submitted, the should we say AECB central office will then send out a certificate that confirms compliance, and that can be presented to the client, and everyone could be happy. So challenges in design and build contracts: who should be the certifier, and should the certifier be novated? Well, arguably, for that to maintain that third-party independence, then really we can ask the question: is it appropriate that the certifier should be novated over? Having said that, I have acted as a certifier that has been worked under that novated scenario, and basically a contractor with scruples is not going to be putting pressure on people to kind of distort the truth, should we say. That as always, everyone's always focused on trying to do the best that they can. But I think that for those clients that feel that they would benefit from not novating a certifier over, then I can understand that perspective, certainly. There are a wide range of choices. Means the design team could spend more time choosing rather than doing. I think that's one of the issues that can arise with the AECB building standard. Passivhaus is very clear. You've got MBHR, should we say? You've got some very clear air tightness targets. There's less flexibility in that, and those constraints can be very useful. In a scenario with the AECB building standards where you've got some more flexibility, experience really comes to the fore. So speaking to experienced consultants really pays dividends in this particular context. And then you might have concerns over whether comfort will be compromised. Well, I think that can be addressed by making sure that you do still target some good standards of air tightness, and going back to the windows example, avoiding downdrafts and things by putting radiators under the windows, or using the window specifications which can be derived from that graph, are well worth considering. Okay, so next steps. Basically, so can I get help with my project? Well, basically, do you need further help as a client? Then the AECB building standard, you're going to decide whether it's right for you, and therefore appoint a suitable experienced certifier. If you're a certifier, then and you're in doubt, then generally speaking, what we're saying is it's as per the Passivhaus quality assurance methodologies. But if you do have any further queries, then please reach out to us. Technical queries, for certifiers, reach out to us at contact us at aecb.net or AECB certification at aecb.net. Okay, so now it's top of the hour, and it's time for questions. And if you want to reach out to me, by the way, you can find me on Twitter And so that's my handle's down on the right hand side here. Okay.
Okay,
So,
Mark.
questions.
Right, I'm going to just, lots of people have put them into the chat.
Yeah.
I'm going to have to just switch between two. Okay, I'm going to start with the ones in the Q&A box. So Sean Richards asks, what does it look like for low-rise flats?
I don't understand the question. It's the same with everything that I've just outlined.
Okay, all right. And what is the difference in cost between Passivhaus and AECB?
We don't have that full level of cost data. At this particular point in time, there is just so many variables. It's been very hard for the Passivhaus Trust to really gather data for Passivhaus buildings, to tell you the truth.
Yeah.
Certainly when you start to talk about projects whereby the ground conditions can add kind of 15% to a project. We don't have consistent cost methodologies that would that allow us to make those comparisons at this particular point.
Okay, cool. And okay. So the same, well, it's not just about the costing. So Kerry asks, may I ask what the difference is between Passivhaus and the AECB Building Standard? Are they just simply different routes to a high-performing building?
Okay, well, hopefully I've outlined this in the presentation, but basically the Passivhaus standard sets more onerous space heating demand targets and more onerous air tightness targets. Those are kind of the key differences. Both of them are, one of the things that's a concept that I'm currently playing with, should we say, and talking to with the ACB and the Passivhaus Trust about, is how these are basically two stepping stone standards. Basically step codes that work together with one another. So if you're going from building regulations and you're hesitant, then you might stop temporarily at the AECB Building Standard and then progress to Passivhaus. Alternatively, so there's a kind of a continuity in those different standards and how they relate to one another. But because they're all using the same quality assurance framework, we know that the Passivhaus standard closes performance gaps where the AECB Building Standard is built upon that solid foundation. So it's not just a key to this is using PHPP and the skills of certified Passivhaus designers and the likes, so that we're going to deliver buildings that perform in practice, which is kind of our key interest, shall we say.
Okay, thanks, Mark. And okay, is nuclear energy classed as renewable for your calculation purposes? That would be rather unfair, since we do not yet know the true costs of nuclear decommissioning and end disposal of its products. The UK government decommissioning programme is currently 25 years behind schedule.
Basically we're using the Passivhaus Institute's PER methodology, and you can read more about that when you do a search for that on Passipedia. I'm not aware of it having any inclusion for any nuclear power in that framework.
Okay. And can the standard be incorporated in BIM model calculations, e.g. in Vectorworks Energos? Are you able to accept Solibri IFC models for certification purposes?
The Passivhaus planning package is the approved calculation process, so you may be able to export from PHP. You might be able to export from certain key data from your BIM tool. You can set up different layers and things to export the areas, and so they can be imported into PHPP. So BIM could be made to work with that, but you should be using the Passivhaus planning package.
Brilliant, thank you, Mark. Can the various design criteria variables be built into BIM software? Vectorworks already does this, and Mark Stevens, RIAI, is assisting NetCheck and Passivhaus calculation built into the design software. The impression here is that of rather tedious referencing external Excel spreadsheets and finally submitting in PDF format, which seems cumbersome. Whereas PAS 1192 BIM certification and the CIC contract BIM protocol require an IFC project model. I'm not sure if that's a question or much as a comment.
No, not I think, yeah, I'll go back to the one whereby data would be exported into PHPP.
Yeah.
The first part of the question is that other software tools haven't been proven to be creditable when when we're looking at space heating demand targets. Anybody can calculate nonsense, but having a reliable benchmark means using tools that have known boundary conditions and have been shown and proven to work. And that goes back down to well, one example here is after the Passivhaus arena, but I co-authored a peer-reviewed paper with Wolfgang Feist, who developed the Passivhaus standard, Dr. David Johnston from Leeds Beckett University, Soren Pepper from the Passivhaus Institute, and now his name's escaping me, so apologies to our other co-author, Oliver Carr. Sorry, name's escaping. But basically, we looked at over 2,500 certified Passivhaus dwellings, and the Passivhaus standard, all of the houses were performing as expected for both retrofit and for existing new homes. It's off the back of that sort of knowledge and awareness that the AECB Building Standard has a creditable position, whereas we haven't found similar supporting data for anything associated with other energy standards that we know of.
Okay. And okay, next one, Nick says Passivhaus / PHPP as part of BIM seems like a natural fit. Obviously, you need people with a very strong understanding of both disciplines, though, and I would expect that some values will need to be inputted. For instance, thermal bridging, unless you want to take the building modelling to an almost ridiculous degree.
Yeah, I think that might be Nick responding to some of those previous questions. So yeah, I mean, I think Nick raises an important point there that BIM tools can't do finite element analysis, so they can't do thermal bridging analysis. Similarly, so there are limitations in what a BIM tool can do in that respect.
Okay. And shouldn't the origin of insulation materials be factored in sustainability metrics, e.g. petrochemical derivatives such as Kingspan's PUR and Dow Corning's
isocyanurate.
Well done, thanks mate. Insulation are both toxic and combustible. Would the AECB standard accept any of those materials in their standard?
Well, the building standard, that's where we the life cycle carbon targets start to kick in and play a key part. Again, when we look, when I'm not, I don't disagree with the intent of designing that out, but the building standard itself, there are certain situations where foam-based insulations have an appropriate use under floor slabs, for instance. So it's not going to be one whereby thou shalt not be used ever. It's a case of it's at the designer's discretion. The key thing is we're providing the framework for sensible decisions to be made.
Okay, questions are still coming in. We've probably got another maybe 6 or 7 things to get through in one person.
I'm here to answer all the questions.
Awesome, Mark, brilliant. Okay, just to mix it up a bit, we've got someone with their hand raised, so I'm going to bring them in. It's Paul Cayford. So Paul, you've raised your hand. I'm going to allow you to talk. If you want to unmute yourself, Paul, as well.
No, I'm sorry, I didn't mean to do that. I'm enjoying the show, but I'm Didn't mean to ask a question.
Raise your hand.
Well, thanks for breaking it up,
No problem, Paul. Have you got a question while you're on? No, we're putting you on the spot now. We'll let you go. Cheers, Paul.
Thanks.
Thanks, bye. Okay, well, that failed. Back to questions. Okay, we've done that. Are there requirements for end-of-life treatment that is acceptable for the standard, e.g. incineration versus recycling or reuse of materials?
Well, this goes, so where you're talking about the life cycle standard, life cycle carbon standard now, basically this is, we're following the methodologies set out in the European standards, and therefore, basically, and also tying in with our ICS standards as well, which recognise that combustion happens at the end of a life cycle at the moment. We're not kind of involved in fanciful thinking about possible futures where everything's going to be miraculously recycled. We're working with current benchmarks. In that respect, that's addressed.
And is there a check on adjacency limits for thermal envelope elements, i.e. the U values of immediately adjacent thermal elements should not differ by more than 75%?
That's not, no, there's no requirement for that as far as I'm, no, there's not, I've never come across anything like that before.
Yeah, okay.
When we're assessing, when we're looking at thermal bridges, then there are certain rules of thumb that certified Passivhaus designers are aware of, and that could be used for assessing whether a design is thermal bridge free. But yeah.
Okay, thanks, Mark. Is it possible to get a CPD certificate for this presentation?
No. There isn't a specific certification certificate that's available.
No, there's not.
As an architect, you can log your hours and log that time as part of the CPD process.
Okay, that's brilliant, thank you. And why is D and B not actively discouraged, as per each home counts findings and numerous other painful and costly experiences?
Because we're not trying to, we're not, as the AECB, we're not sort of legislating everything out there. Well, there are projects. There are projects that are designed and constructed using design and build that can be done properly. I'm speaking personally now. I'm not endorsing or unendorsing design and build. It can all be but it's for each individual project to make its decisions about that. There are consequences to those decisions. Again, an experienced AECB certifier would be able to guide your thinking on that.
Okay, that's good. Okay, this must be, so it's not from a particular person, so I can't link it back. Oh, okay, I think it was about the flats when we asked. So my question was in relation to an earlier slide that showed example U values for semi and terraces of different sizes. Was curious about how a 3 or 4 story block would compare. No need to answer again. Oh.
Well, okay, the one comment I'll say is, well, break out your PHPP and do the calculations. I've given some rough examples there. Basically, what we've said is form factor is important. An important consideration, and we've given some outline specifications.
Okay. Okay. So about the vector project, someone says that they think we've misunderstood the question. As an architect, they want the design criteria inside the software for workflow efficiency. You need to work with Mark Stevens and Vectorworks so that PHPP is an add-on for the software.
No, Vectorworks, I'll flip that around and say that Vectorworks needs to approach the AECB about integration if it wants that. We're a small, modest-sized membership organisation with limited capacity. If Vectorworks wants to work with us to help integrate that, I mean, I know Mark in general terms, should we say? So yeah, happy to continue those conversations, but it's for that, that's the conversation that nobody's approached us about yet.
All right, okay. Someone's making a comment regarding phenolic foam or not. I don't know if you want to say anything about that at all.
Well, again, as I say, there are those situations whereby under a floor slab, it can be appropriate to use foam insulations because they are closed cell. Certainly certain insulations are closed cell and are appropriate. This is not an endorsement. I'm not getting. If you ask, I'm here. I'm responding with regard to what the AECB building standards say. If you're asking me personally, no, I'm not going to be using foam above the floor slab. But but the AECB building standard does not legislate that kind of thing in the same way that other standards do not legislate those kind of things.
Yeah. And would that sort of be the same answer to the next question that's being asked about if the AECB would accept combustible or toxic petrochemical-based insulation materials? Because we're not actually putting out the criteria like you've just said, would we not again delve into that really?
I think that somebody here has just been awkward and
me too. It's all come from the same person.
Just to be the protagonist.
I've skipped a few a bit.
Are there other? Are we talking about here that every single aspect of sustainability has been entirely ironed out and fully addressed? The answer is no. No standard in the world has done that.
Okay. Yeah, I think that answers the person's
question. We are signposting key ways forwards. As always, it's for the creative innovators and people with to help fill in some of the gaps. We're not saying that, we're certainly not endorsing the use of petrochemical insulation materials. There's nothing in what that I've said that endorses any of those things.
Okay. Just going through, lots of people saying thanks, and I think let me just double check we've got another hand up if you're happy to take a question, Mark.
Yeah, as long as they're going to be gentle.
I can mute them if they're not, so don't worry. Okay, Angel, I'm going to bring you in, and if you want to unmute yourself. Hi, Angel.
Thank you for taking my call. My name is Angel, and I just actually wanted to touch on what you were saying about the standard not looking at the whole thing. And in a way, I'm kind of showing my support to what you just said. I think it is disingenuous to believe that the standard will cover everything that relates to sustainability. It's too wide, and there are too many things to consider. I would say to this attendee that if he or she is really interested into these kind of materials, these sort of topics are better discussed when you're talking things like life cycle assessment, where you do consider each material you use in a building and the emissions it has and everything. I mean, I have to say, I'm an architect and I'm a certified Passivhaus designer, and I do myself find sometimes that I have to specify products. I know they're not the greatest, but sometimes we have to do that. You cannot put a wood fiber insulation underneath a slab. You just can't. So there are things to consider. And then I think what AECB does, which is what Passivhaus does, is to try to focus on the first and foremost requirement, which is energy consumption. Yeah. And then from there, you as an architect need to take responsibility to go beyond that and think about low carbon. But you cannot expect any standard to cover absolutely everything. So yes, I think your response was very.
Thank you for your endorsement in that context. As I say, the one of the key ways to drive out and drive down the use of petrochemicals is to complete the life cycle, AECB life cycle carbon analysis, because we know that the embodied carbon of a lot of the petrochemical insulations is very, very high, and we want to get embodied carbon as low as realistically possible, and that in turn encourages the use of more sustainable materials. But when we're frank, we've also got to recognize that wood-based insulations, or some of these more natural-based insulations, which I fully, I love, when they're combusted at the end of the day, the carbon emissions from those are significant as well. And there's a lot that we haven't resolved in the construction industry overall, and there's some really great and useful thinking that's been undertaken by AECB members and and I think that we just, it's a conversation that we're having. There's no, and together we work together to help improve what we're doing. And can and will the AECB building standards continue to grow and flourish and be refined? Yes, that's the one thing that we can say will be happening in the future.
So thank you, Angel. That was a great contribution from yourself. And one last question, Mark, in the Q&A box. Are there other industry comparators to the AECB building standard? Asking in case clients ask the question. It's from Jennifer Senfield.
I think, are there direct comparators? No, I would say, because none of them use the same. The key thing is the quality assurance. I think that and I say this because I'm not trying to compare AECB building standard with Passivhaus. They are two separate things. And they, as I say, the building standard works as a stepping stone towards Passivhaus. There's a big gap in knowledge and understanding between building regulations and doing anything of what we're talking about here, which is why some people find the AECB building standard comforting, because it's there's still a learning curve, but it's not necessarily quite as onerous in some people's perceptions, and I think that's where the building standard fits. But the AECB thoroughly endorses and supports the adoption of the Passivhaus standard, and in fact the AECB helped kind of develop and introduce the Passivhaus Trust and the Passivhaus standard to the UK, so they're very much in alignment with one another. But there are no other standards out there that really compare in an even fashion.
Well, Mark, you've had many just comments saying a very useful presentation. Thank you for answering all the questions, etc. As always, been absolutely brilliant and insightful. And just to let everyone know, this recording will be available shortly after, and we'll also be updating the video on the AECB Building Standard page with this new recording as an update.
Excellent.
So thanks ever so much, Mark, and thank you everyone for joining today.
Yeah, thank you everybody.
All right, cheers. Bye for now.
Bye.